हार्दिक स्वागत हमारा डीबी प्रोडक्शन बीचेस में। डीबी प्रोडक्शन बीचेस अब लेके आ रहा है सीबीएसई पैटर्न के क्लास 10 की मैथमेटिक्स। हम क्लास 10 के मैथमेटिक्स का जो वीडियो है इसको लेकर आ रहा है। नंबर सिस्टम्स, द डेसिमल नंबर सिस्टम्स, देयर आर 10 digits. 10 digits are necessary. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 digits which are necessary to make the decimal digit system. The decimal system, decimal number system, the 10 digits are necessary. We make the number system, decimal number system with the 10 digits. What is the difference between digit and numbers? First of all, the prime things are the digits, 10 digits. They are the seeds of the mathematics, seeds of the number systems. We make all numbers from these 10 digits. So without 0, we cannot make all the numbers. We cannot make 10, 20, 30, we cannot make. So 0 is necessary to complete the number systems. So when 0 is discovered, then the numbers, the natural numbers become the whole number. Natural number become the whole number. That is whole number, n star, yeah, w, any symbol, many symbols, many authors they get and many symbols. So that is called the whole numbers. First is natural number, then second is whole number. Whole numbers, that is that started with 0, 1, 2, 3 and so on. Which is the lowest whole number? That is 0. The lowest whole number, that is 0. But the lowest natural number, that is 1. That is the difference between whole number and natural number. That means natural numbers, when 0 is induced, when 0 is included in the natural number system, that is called the whole number system. That is called the whole numbers. So this is the whole numbers. Whole numbers comes, the lowest whole number is 0. Then when that is integers. What is integers? Integers z. What is integers? When positive integers and negative integers. When negative numbers come. When negative numbers comes, suppose I have 10 rupees. I have 10 rupees in my pocket. But I have to purchase a thing with 15 rupees. So what I shall do? But I have necessary to purchase that things. So what I shall do? I borrow 5 rupees. I borrow 5 rupees from another person and I will start to I purchase the things. So when I borrow 5 rupees from other, but the situation is that how many rupees I have? I have not 0 rupees. I have minus 5 rupees. So that is, in that way, the minus numbers, the negative numbers are negative integers. They are called integers, negative numbers. But negative integers are counts. So that negative integers are minus 1, minus 2, minus 3, minus 4 and so on. Positive integers are 1, 2, 3, 4 and so on. But there is an integer that is neither negative, nor positive. That is called 0. 0 is neither positive nor negative. So the negative integers, positive integers and 0 combinedly they are called integers. Yeah, they are called integers or z. Yeah, that so on, minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. So when we consider the integers, which is the lowest integers? We cannot say. It is in the lowest side, it also extend up to infinity. And the highest side, higher side it also extend up to infinity. So the integers, the lowest integer we cannot say, the highest integer we cannot say. We have discussed about it. Then after the natural numbers, whole numbers, integers, then rational numbers. What is rational numbers? Rational numbers, we have discussed about rational numbers. That is Q. Rational numbers Q. Any number which can be formed by P by Q. Any number. Suppose any number Q equals to P by Q such that P Q belongs to Z, Q not equals to 0. This is the formula of your Q set. P by Q such that means P by Q such that means Q is defined by P by Q. P by Q in the form of P by Q where P and Q are belongs to Z, where P and Q are integers, maybe positive integers, maybe negative integers, and Q not equals to 0. Where this Q not equals to 0. Q will be not equals to 0. The divisor will not be 0. Q will not equal to 0. This is very important factors. Any division process, the divisor cannot be 0 in the real number systems. Up to the real number systems, we cannot take the divisor up to 0. That means 5 by 0, that is meaningless. We cannot divide it. We have not any numbers in the number system, our real number systems. We cannot divide any number by the 0. We cannot divide any number by 0 in real number system. So it should be avoided. So that is the most important point is Q not equals to 0. Most important point. This point is most important that Q not equals to 0. So we should be keep in our vision that Q not equals to 0. This is the simply any number which can be formed as P by Q. When you can write any number in the P by Q, that is called your rational numbers. Suppose 5 is a number, this equals to 5 by 1, that is your rational numbers. 0.3 is equals to 3 by 10, this is written as P by Q, so that is also rational numbers. All your any numbers you can write in the, that means your natural numbers, whole numbers and integers. Natural numbers, whole numbers and integers, they all are called rational numbers. They all are rational numbers. So, beside them, some numbers, this type of numbers, the fractions are also your rational numbers. All type of fractions we have discussed in the last class, the small class 6, 7, 8, 9, 10, 8, 9, all classes, all the fractions we have discussed, they are called rational numbers. All fractions are rational numbers. That means any number which can be formed, we write in the with respect of P by Q, that is called your rational numbers. Then irrational numbers. That is QX. Irrational numbers, the number which cannot be formed as P by Q. We cannot write. If we cannot write any number with respect of P by Q, that is called irrational numbers. Suppose several irrational numbers are we have discussed. That is root 2, root 3, root 5, root 6, root 7, root 8, root 10, pi, e, etc. and so on. This is also uncountable. Irrational numbers are all numbers systems are on-countable systems. All number systems, your natural numbers, whole integers, rational numbers, irrational numbers, your real number also, they all are countable numbers. We cannot count. We can count, but counting process will not stop. When we count a natural number 1, 2, 3, 4, 5, we count and count, time will lapse, the counting process will go up to our death, but the counting process will not stop. That is uncountable. That is uncountable numbers. Rational numbers, irrational numbers. Then we will discuss the number systems detailedly. Irrational numbers, rational numbers. So many things are there. We have to discuss about after that. But that is next is your real numbers. We discuss overview. The number systems very clearly. We identify the definitions. The number systems. We think the numbers. They are series. Their system. Their series. Very clearly identify themselves. Very clearly. That is called your number systems. We have to discuss about it. Real numbers. That is called your R. Real number R. That means numbers combinedly called real numbers. R equals to Q plus Q dex. Q plus Q dex means all rational numbers and irrational numbers. All rational numbers combinedly they are called the real numbers. That means real numbers. Real numbers consist of Q and Q dex, means rational and irrationals. Irrational separate things. Rational numbers consist of your rational consist of integers. Z consists of n and positive integers, negative integers. And n star consists of, means all numbers of n, natural numbers, are present in the whole numbers. In the whole numbers are integers. All integers are numbers. All rational numbers are real numbers. That means this is the real number systems. This is the protocol diagram. This is the algorithm, and this is the diagram of the number systems. We have discussed the fundamentals of the number systems, the fundamental things we have discussed in the class 8, 9, the lowest class, fundamentals of the number systems. Now we are going to discuss about the Euclid. First of all, about algorithm and lemma. What is algorithm? Algorithm and lemma. Lemma is the proven statement. Lemma is the proven statement which is used to prove another statement. That is called lemma. Lemma is a proven statement. The statement which is proven earlier. That is called lemma. The proven statement. Suppose any proven statement. Suppose A plus B, the whole square of A plus B the whole square, this is equal to A square plus 2AB plus B square. It can be considered as a lemma. Suppose the angles are the sum of all angles of a triangle is 180 degree. That can be also taken as the lemma. Lemma means any proven statement. Any proven statement which is used for proving another statement, that is called lemma. But algorithm. What is algorithm? Algorithm is the steps, continuous steps which is used for solving problems. The continuous steps. Suppose any step continuously, one by one, serially we take any steps, continuous step, that is called your algorithm. That is the difference between algorithm and lemma. Now we discuss about we have to discuss about Euclid's division lemma. Euclid's division lemma, EDL. What is Euclid's division lemma? First, we have to discuss about Euclid's division lemma. Euclid's division lemma, suppose division process, we have to first know what is division process. Any numbers and division lemma, any number, suppose A and B are two numbers. Let A and B are the given positive integers. Given positive integers A and B, where A greater than B. Where A greater than B, A is greater than B. In the division process, the greater number will be divided by the smallest number, or the greater number will be divided by the smaller numbers. So A is divided by B. A will be divided by B. This is most important Euclid division lemma. Any given positive integers A and B, where A greater than B, there exist unique integers Q and R satisfying A equals to BQ plus R. Suppose BQ, B into Q, BQ, then when we subtract A from BQ, then we get the remainder R. Q and R two integers, which satisfy A equals to BQ plus R. Q and R, A and B, where A equals to BQ plus R. This is called your Euclid division lemma, where we have to keep in mind that 0, this R is less than B. When R will be greater than B, when R is greater than B, then what happens? We take another division process also. When R will be the remainder, R will be the less than B, then the division process will be stopped. In the year, according to Euclid division lemma. Euclid division lemma, division process will be stopped when R less than B. But keep in mind, 0 is less than equals to R less than B. That means remainder may be 0 or greater than 0. That means 0 is less than equals to R, may be equals to R, but 0 is less than R. That means R is a positive integer. R must be a positive integer. 0 is less than equals to R, less than B, when remainders. This will be very important factor. Suppose in the division process we have to divide any two numbers. Suppose 17 divided by 3. 17 divided by 3. 3 5 are 15. Then when you subtract 17 minus 15, that will be 2. Remainder will be 2. That means in the process 17 greater than 3. 17 will be greater than 3. So 17 equals to 3 into 5 plus 2. 17 equals to 3 into 5 plus 2. According to A equals to BQ plus R. A equals to BQ plus R. This is the process. This is the Euclid division lemma. We have to discuss. 17 equals to this 17 equals to divide n. Divide n equals to divisor into quotient plus remainder. This is your Euclid's division lemma. That means any number when is divided by your divisor into quotient plus remainder, this equals to dividend. That means A equals to BQ plus R. When Q plus R satisfied, that A equals to BQ plus R, A equals to BQ plus R, when 0, this point is most important, 0 less than equals to R, less than equals to B. This is your Euclid's division lemma. Using the Euclid division lemma, we can solve any problems, so many problems. Let us discuss about our exercise 1.1. What is Euclid's division algorithm? Euclid division algorithm. How can we discuss about Euclid division algorithm? Using algorithm means this division process when we proceed continuously Euclid division lemma, that will call Euclid division algorithm. So using this continuous division process, we can find the HCF of any two numbers, highest common factors, that is your highest common factors, HCF of any two numbers. Any two numbers, we can find the HCF of any two numbers. Suppose, for example, I will take two numbers. (96) and 45. Two numbers, two integers, two natural numbers also, two integers are there, 96 and 45. We have to find the continuous process, A greater than B, that means 96 greater than 45. So we have to divide 96 divided by 45. 45 2s are 90. Remainder will be 6. In the process of your Euclid's division algorithm, EDA, the division process will not stop in this place, but according to EDL, Euclid division lemma, the division process will stop here. But the algorithm, according to Euclid division algorithm, the remainder is not 0. When the remainder will be 0, then division process will be stopped. Then what will do? Then your divisor comes to the dividend place. And 45, here 45 will be divided by 6. So 45 will be divided by 6. 6 7 are 42. Minus 45 minus 42, 3. Then also the remainder will not 0. Then what happens? Then the divisor will become to dividend place 6. 3 2 is 6. Now the remainder will be 0. So HCF, here HCF equals to 3. The last divisor, when the keeps the remainder 0, the divisor which let the remainder 0, that will be your HCF. That means HCF of 96 and 45, that will be 3. HCF of 96 and 45 will be 3. So according to Euclid division algorithm, what happened? 96 equals to 45 into 2 plus 6. 96 equals to 45 into 2 plus 6. Then remainder will not 6. Then second process, this is 45. 45 comes to the dividend place. 45 equals to 6 into 7. 6 into 7 plus 3. 6 into 7 plus 3. Division process not stop. Thirdly, then 6 will become 6. This 6 will come to this place, dividend place. 3 into 2 plus 0. 3 into 2 plus 0, the remainder will be 0. Then your HCF is 3. HCF equals to 3. This is the Euclid's division algorithm. This is the algorithm. In this process we can find the HCF of any two numbers. Any two numbers HCF we can find dividend equals to divisor plus quotient, divisor into quotient plus remainder. When to find the remainder 0, the last divisor will be your HCF, highest common factors. And using the Euclid division algorithm, we can find the your HCF. Then we come to exercise 1.1. Very easy process. Exercise 1.1. We have to discuss. Use Euclid division algorithm. Find HCF of 135 and 225. Exercise 1.1. Here question is use Euclid's division algorithm. Use Euclid's division algorithm. Find the HCF of 135 and 225. 135 and 225. Here we have to say we see that 225 is greater than 135. 225 is greater than 135. So A greater than B, then this will be the dividend, this will be the divisor. 225, this is the algorithm. 225 divided by 135. 135 1 is 135. 5 minus 5 0. 12 minus 3 9. 90. The division process will not stop. Then what happened? Then 135 will be dividend naturally. 91 is 90. 5 45. Then same process. 90 45 2 is 90. So 0. Then HCF equals to 45. This is the algorithm. This is the process. This is the natural process. Naturally you can do this. HCF will be your 45. But in this process, in the algorithm process, according to your Euclid division algorithm, what is the algorithm? 225. This equals to 135 into 1 plus 90. 90 will be a remainder. When remainder is not 0, then this 135 will be dividend. 135, this equals to 90 into 1 plus 45. Then remainder will not 0, then 90 will be dividend. 90 equals to 45 into 2. This remainder will be this remainder 45 into 2 plus 0. So HCF equals to 45. HCF equals to 45. So in this way, we can find the HCF. We can find the HCF of any two numbers using this Euclid division algorithm. And one division, that is Euclid division lemma. That is the lemma is the process or the proven things. The proven any proven statements. They are using to prove another statements. Or another statements they are lemma, but this is the algorithm. We use the lemma to prove the algorithm. Then secondly, your 196 and 38,220 you can do yourselves. 867 and 255 also you can do yourselves in the same process. I think we have all of you learned, all of you understand the process, the algorithm process very clearly. So you can do this in your home clearly. Then number 2. Then number 2. What is the question of number 2? Number 2, so that any positive odd numbers is in the form of 6q plus 1, 6q plus 3, 6q plus 5, where q is in some integers. Very important questions. so that any positive odd numbers, odd number means which is not divisible by 1, which is a 2, which is not completely divisible by 2. Suppose according to Euclid division lemma, A equals to, according to PDL, A equals to BQ plus R. A equals to BQ plus R. We know that A equals to BQ plus R when B equals to 6. If when B equals to 6, then B equals to 6 means R. We have to mind that when B equals to 6, A equals to 6Q plus R. 6Q plus R, where R 0 less than equals to R less than 6. This is the most important point. That means R, the value of R will be 0, 1, 2, 3, 4, 5. R equals to. The possible numbers, the possible outcomes of the R are 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. R can be 0, 1, 2, 3, 4, 5. Any one numbers, not all the same numbers. So A can be A equals to 6Q plus 0, 6Q plus or anyone, 6Q plus 0, 6Q plus 1, 6Q plus 2, 6Q plus 3, 6Q plus 4, 6Q plus 5. These are the outcomes. These are A can be the A number 6Q plus 1 when R equals to 0. This is 6Q plus 0. When R equals to 1, A equals to 6Q plus 1. When R equals to 2, A equals to 6Q plus 2. When R equals to 3, then A equals to 6Q plus 3. When R equals to 4, A equals to 6Q plus 4. And when R equals to 5, A equals to 6Q plus 5. So any one number, any one possible outcomes. So question is that, what is the question? So that any positive odd integer, so that any positive odd integers is of the form positive odd integers. That means suppose this 6Q plus 0, this equals to 6Q, this equals to 2 into 3Q. This is the even numbers. 2 into even numbers can be written as 2m. So even numbers, we can write even numbers, this equals to 2m, and odd numbers equals to 2m plus 1. These are the forms, general forms of even numbers and odd numbers we have discussed in the class 9. In the class 9, the general form of even number is 2m and the general form of odd number is 2m plus 1. So the 6Q plus 0, first outcomes, 6Q plus 0, this equals to 6Q, this is a even numbers. So we cannot count as odd numbers. Another is 6Q plus 1, second outcomes equals to 2 into 3Q plus 1. 2m plus 1, this is maybe odd number. Whatever may be the cube, whatever the value of the cube, we can find this is a odd number, because when we 3Q and multiply with 2, then this is the even numbers. So plus 1, even number plus 1, that will come odd numbers. In the general form, 2m plus 1, 2m plus 1, that is odd numbers. Then second is 6Q plus 2, this equals to 2 into 3Q plus 1, this equals to the even numbers. We cannot count as the odd numbers. This is the even numbers, 2 into m, 2m plus. Then next is your 6Q plus 3, this equals to 6Q plus 2 plus 1, this equals to 2 into 3Q plus 1 plus 1, this is 2m plus 1, this is m, 2m plus 1, this is the form, this is the odd numbers, this will be the outcomes of odd numbers. Then other other is 6 cube. Next number is 6 cube plus 4. This is also 2 into 3 cube plus 2. This will be your even numbers. That come numbers in the range of the odd numbers. Other is 6 cube. 6 cube plus 5. This equals to 6 cube plus 4 plus 1. This equals to 2 into 3 cube plus 2 plus 1. This will come at the odd number systems. This will be the odd numbers. So possible outcome of the odd numbers are first your odd numbers is 6 cube plus 1. Possible odd numbers. Another odd number is 6 cube plus 3 and third is 6 cube plus 5. That is proved. We have proved that the positive odd integers in the form of 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5 where q is an integer. This is all about the number 2. Now we have to go into number 3. Number 3. Number 3 questions. An army contingents of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same numbers of columns. What is the maximum number of columns in which they can march? Question is that the army contingent of total number is 616 members is to march behind any army band. Second army band is 32 members in the parade. So the two groups are to march in the same numbers of columns. The column number will be same number of columns. So we can find the HCF of two numbers, then find the total number of columns. What is the maximum number of columns? What is the maximum number of columns in which they can march? So 616 and 32. We have to find the HCF of 616 and 32. We have to find out the HCF. 1 32, 11 minus 2, 9, either 5 minus 3, 2, 6. 9, 9 2 ja 18, 1, 9 3 ja 27, 1 28. 16, 8, 8, yeah, 32. Remainder will not be 0, then 32, 4 ja 8 4 ja 32, then there will be 0. So 8 will be LCM. LCM equals to 8. So LCM equals to 8. So the maximum number of columns which can be made between 616 number of groups and 32 number of groups. That will be maximum number of columns will be 8. The maximum number of columns will be 8. That is the number all about number 3. Then we have to go to number 4. Number 4 and number 5. They are very symmetrical numbers, very same type of numbers we have to discuss. Question is use Euclid division lemma to show that the square of any positive integers is either of in the form of 3m plus 1 for some integer m. Any Euclid division lemma show that the square of any positive integers. We know by Euclid division lemma A equals to BQ plus R, where 0 less than equals to R less than B. This is the most important point. 0 less than equals to R less than B, very important. So if B equals to 3, question is given that in the form of 3m and 3m plus 1. So we take B as 3. If equals to 3, when takes b equals to 3, a equals to 3q plus r. That means 0 less than equals to r less than 3. So the possible outcomes of what are the possible outcomes of r equals to 0, 1 or 2, anyone. 0, 1, 2, that cannot be 3 because r is less than 3, so the possible outcomes of r are 0, 1 or 2. So when r equals to 0, a equals to 3q, a equals to 3q plus 0, this equals to 3q. The question, what we have to prove? Euclid's lemma, so that the square of any positive numbers, this is the positive numbers, we have to take squares. A square equals to 3q ka square equals to 9q square. 9q square, this equals to 3 into 3q square. This equals to 3m. A square equals to 3m. First you will form 3m or 3m plus 1. We have to prove that any square of any positive numbers, we can write them as the form of 3m or 3m plus 1. Second one is when r equals to 0, when r equals to 1, then a equals to 3q plus 1. A square equals to 3q plus 1 ka whole square. This equals to 3q ka square plus 1 ka square plus 2ab, 2 into 3q into 1. This equals to 9q square plus 1 plus 6q. This equals to a square equals to 9q square plus 6q plus 1. This implies a square equals to 3 into 3q square plus 2q plus 1. This implies a square equals to 3m plus 1. This will be second form. First will be 3m plus a square equals to 3m in the form of 3m. Other will be 3m, 3m1 and 2, 3m2 plus 1. And the third is when r equals to 2, when r equals to 2, a will be 3q plus 2. A will be 3q plus 2. So a square equals to 3q plus 2 whole square. This implies a square equals to the 3q ka square plus 2 into 3q into 2 plus 2 ka square. This implies a square equals to 9q square plus 2 3 ja 6, 6 2 ja 12, 12q plus 4. This implies a square equals to 9q square plus 12q plus 3 plus 1. This implies a square equals to 3 into 3q square plus 4q plus 1 plus 1. This implies a square equals to 3 and 3 plus 1. 3m plus 1. A square equals to 3m plus 1. So I disprove that, hence proved. When any positive integers a square will be in the form of 3m, 3m plus 1 or 3m plus 1. That is proved. Then number 5. We have to last number 5, exercise 1.1, number 5. Number 4 and number 5, they are the same process. If we discuss themselves very clearly, we can find the numbers when we take the a cube. Here, when we take the number 4, a square, then that will be take a cube, then find the answers. So number 5 will be the exercise home task for you. You have to prove that, you have to start learn that. Then practice them the number 5. Before concluding, I say that you must go through the DB production teachers, like, subscribe, and leave being with the DB production. Thank you.
क्लास को क्यों नहीं है मेरी वामा भी चाहते उत्साह बोली मैं ସବୁଦିନ ମାନେ ଡାକି ନାହିଁ କାଲି ଦିନ 2006 ଏମକୁ କାଲି କେତେ ବେଲେ ଶୋଇଛକି କାଲି ମୁଁ ବଢ଼େ ବସିଥିଲି ସେ ବଢ଼େ ବସିଛି ହଁ ତାର ବାହାରେ ମୁଁ ଉଠିଲା ବେଳେ 7:30 ବଜେ ଏନ୍ତା ମୁଁ ପାଖ ପଢ଼ା ଛୁଆ